Hey guys, welcome to today's video on Lewis dot structures. The subject of today's video is the Kelter method, which is a more mathematical approach to the subject. So there are 4 rules to this method. First rule is that you add together all the valence electrons. And if it's an anion and has a negative charge, you will add to those electrons, which means, say if your polyatomic ion has a charge of -2, you will add 2 electrons to the valence electrons. But if it has a positive charge of 2, you will subtract 2 electrons because that will make it a positively charged ion. The second step is that you add together all the electrons to satisfy the octet rule or duet rule of the molecule or polyatomic ion. I will explain what the octet and duet rule means later in the video when we will be doing some questions. And the third rule is that you divide by 2 the value that represents the number of bonds around the central atom, which basically means, say if we have a Lewis dot structure of this, each of this line represents 2 electrons that are being shared. So that is why we will be dividing it by 2. The fourth rule is that starting with the terminal atom, we add dots until our number of valence electrons is achieved. And if all the valence electrons have dots and more need to be added, place them into the central atom. Now let's try doing some problems. Let's look at rule number 1. We need the total amount of valence electrons in this. So oxygen has a total number of 6 valence electrons, and nitrogen has a total number of 5 valence electrons. Since there are 3 oxygens, 6 times 3 is 18. 18 plus 5 is 23. But we have a -1 charge, which means we will add 8 valence electrons. So the total number of valence electrons is 23 plus 1 is 24 electrons. Now, let's see if our polyatomic ions follow the octet rule or the duet rule. So what that means is, can the element in its valence shell, in its last shell, hold 2 electrons, a total of 2 electrons, or a total of 8 electrons? So oxygen, we know, can hold a total of 8 electrons. Nitrogen can also hold a total of 8 electrons. So 8 times 3, 24. 24 plus 8 is 32. So since the elements in our polyatomic ion follow the octet rule, the total number of electrons would be 32. Now subtract the second value with the first number of electrons, and we get 8. Now what we're going to do is we're going to divide this number by 2 and get 4 bonds. Now dividing it by 2 gives us the total number of bonds, because remember, one line represents a bond, and every line has 2 electrons, and I'll show you that later. So what we can do is now we can form our central electron, which means central atom, which is nitrogen, and then around it we will make oxygens. So we can make it, so we always have to try to make it symmetrical. We make this, and we go oxygen, oxygen, oxygen. Now we've seen that we fulfilled the number of oxygens we need, but have we fulfilled the number of bonds? No. So since nitrogen and oxygen can both form double bonds, we can put a double bond anywhere we want. So I'm going to put it here on the top. Now we see we have the total number of bonds, and each of these bonds shows 2 electrons bonded with each other. So right now, let's see how many electrons we have bonded. 1, 2, 3, 4, 5, 6, 7, 8. So we need to fulfill this amount of electrons. So since we only have 8 bonded right now, we'll subtract 8 by 32 and we still need 24. And so now the fourth rule is that we fulfill the number of electrons we need by adding dots. So here what we'll do is we know we need 24 more electrons, and we know that each oxygen can only hold 8 electrons in its valence shell. So we know this already has 4. So we go 1, 2, 3, 4. This will fulfill this oxygen requirement of 8. We'll go here. We know this only has 2. So 1, 2, 3, 4, 5, 6. Now this oxygen has fulfilled its requirement of 8. Now let's go the last one. 2, 3, 4, 5, 6. Now we know that this has also fulfilled its requirement of 8 electrons. Now let's count all the electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We have the total number of 24 electrons. And now that we know we've formed our Lewis dot structure, the last step would be, since it's a polyatomic ion, we will always put this in brackets and put the charge that is represented here. Now let's try ammonium. So step 1, the valence electrons. Hydrogen has 1 valence electron. So since there are 4 atoms, we go 4 electrons. And then let's see nitrogen. Nitrogen has 5 valence electrons, so 5. 5 plus 4 is 9, but we have a positive charge, which means we're going to lose an electron. So we'll have a total amount of 8 electrons. Now let's have 2, the total amount of electrons. This is the valence electrons, the total amount of valence electrons. 2 will be the total amount of electrons. Now nitrogen. Nitrogen follows the octet rule since it can have 8 electrons in its valence shell. But hydrogen follows the duet rule since it can only have 2 electrons in its valence shell. So we will have 2 times 4 is 8, plus 8 is 16. 16 electrons. Total amount of electrons, valence electrons, we subtract in step 3. We go 16 minus 8 equals 8. Number of bonds, 2 equals 4 bonds. Again, like our nitrate. So now let's draw our ammonium. Central atom, nitrogen. We are looking for symmetry. So our bonds, we draw our lines here. We have our hydrogens. Now what we will do, we'll confirm all our steps. Do we have 4 bonds? 1, 2, 3, 4. Yes. Do we have 8 valence electrons for each? 1, 2, 3, 4, 5, 6, 7, 8. So we've fulfilled these requirements. So do we need a step 4? No, because we already have all of our valence electrons in our bond, so we don't need any dots around the outer atoms. So our last step being make a bracket, since it's a polyatomic ion, and represent the charge as a plus. Now let's do one more question. This is per bromate. Now as I number the steps, if you would like to pause and try it on your own, you are most welcome to do so. So step 1, valence electrons. We see here there are 6 total, so 6, and bromine is 7. 6 times 4 is 24, plus 7 is 31, but again we have a negative charge, so that would be 32 electrons. These are the valence electrons. Now we need to see the total amount of electrons. Both of these follow the octet rule. 8 times 4 is 32. 32 plus 8 is 40 electrons total. Now we do step 3, 40 minus 32 equals 8 by 2 equals 4 bonds. We have 4 oxygens. We'll have bromine at the middle. Now let's confirm. We have 4 bonds, but this makes how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. We still need 32. So what we'll do is we see all these oxygens already have 2 electrons attached to them, or they're already bonded with 2 electrons, so they each need 6 more. So let's put dots. This is step 4. These are representing the amount of electrons in the valence shell. So now let's count to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So even since we have a polyatomic ion, we also must end with a bracket and the charge. This last question also marks the end of today's video. Hope this helped. Have a good day and thank you.